Recording is on.
Yeah, I'm just not going to a barber and just like combing back. And
Yeah,
I'm starting to look like an evil villain.
as opposed to the not evil villains.
I was about to say that. Yes, I did pick myself up in my own head before you said that, for the record. Okay, so
Okay, here we go.
where
Game
are we
time.
at? Where are we at?
Can you see the screen?
Yes, I can.
I've got a. First of all, I'm sorry, I don't have the thing yet. You can see my mouse and stuff.
Yeah. It's pretty responsive as well. So
Okay, great.
very good.
I don't have the thing. I'm real sorry. It is extremely close, like extremely close. What I do have is I have agent starting. You can create faces. You can interact with the faces. But the bit I'm on now is making a proxy so that you can come in from the outside and you get repointed at whichever agent and whichever face and whichever view you're supposed to do. So it's really just it's just been a lot of trying to make it all work at once. Like there's a lot of all those functions have to be met by this one web server that runs
Hmm.
as like the agent controller. And so I've just been feels like painfully slowly picking together those bits and jiggling them around to make sure they fit and they don't do stupid things or weird things, and then trying to figure out how to test the damn thing. And then yeah, so it's I don't know, I don't, it shouldn't be taking this long, but it's like kind of like it's sort of half runs. Honestly,
Okay.
any hour now sort of thing. Like it's like I'm just jiggling bits around and fucking around with cloud stuff, local stuff, web servers, MCP
Yeah.
servers, um,
Yeah,
codecs,
no,
the
I get it.
CLI, like
Yeah.
standard in, standard out, receiving notifications. It's like this like horrifically
Yeah,
glued
plumbing.
together thing, actually.
Yeah, plumbing, not architecture. Yeah.
Yeah, yeah. But what I did, I'm feeling very comfortable with the design, I guess. Like faces is great. I can actually make faces that do loads of different things. Um, the design is clear, the logic checks out, it all kind of makes sense. Yeah. So
Yeah. Well, on my side, thank you for sending over those links um, to the McNapp, which we probably do need to think about the name for that. But that format really is a beautiful format to work with.
yeah. What do you mean the
Um,
Toml format?
yeah. Hold a second. Let me pull it up. Um, the single shot to go to where you
Oh,
describe an agent
right. The fact that it's all in one place.
that makes now this might be non-obvious, but that makes a world of difference
It does, eh?
because it's like right, I'm working on one thing, and this is like a meat brain problem. um, I do not have to go and worry around how things
Yeah, well
interact.
that's the problem, right? Is the the current way of doing things is all these different bits that you got to pull together,
Right.
you know,
Yeah, exactly.
not a
And you
unit.
got some of these agentic platforms have been working, or just testing around.
Yeah.
You got to they go the GUI route mostly, so
Yeah.
you've got a block, and then you need to like, oh,
Yeah.
get a connector, and then pull a connector,
I
and it's
know.
like,
And you're like, that is never ever going to run on my infrastructure. Just the fact that that GUI is there with all its complications, I'm like, I don't even know what that means. That thing.
yeah, yeah. And the important thing is, I don't know how to ask an AI what that means.
that's the hard bit, right? The system has to be self-aware, like it has to be able to run itself. And so the model that we've got here allows for the human and the AI share the same interface. You wouldn't know if you were being driven by an AI or a human because
Yeah.
it all looks
Yeah.
the same. And I think there's still a few areas of this thing that we haven't quite capitalized on because it's sort of just dawning on us, but it feels like one of those natural cut lines in, like a lot of things fall nicely with this model. So I love it. I still love it.
I'm totally like balls in on this one because
That's not how I just
so I spent yesterday thinking through. Okay, so we got a hopper of various things that we need to do. What would we need to do first? Well, I'd like to get using um, the the format to generate other agents that do stuff, and uh, it seemed quite simple.
Yeah, right.
It didn't. There was no great learning curve around it, which is really important for
Mm.
adoption and all that kind of good stuff. But the important thing is I could understand that, okay, so it's doing something I didn't really want it to do, and I know where to go in and edit it. Um, it's kind of bare metal AI, if that makes sense.
Yeah, yeah, because all these other platforms, it's like, well, where is that running, and what's on it, and what
Yeah,
can I change? Do I have to wait for a div before I change it? Like, why isn't
well,
it agents running?
exactly. And I know I'm repeating myself, but how do I ask an AI with one of these GUI box, agentic systems? How do I ask it what to do next?
Yeah, right. So really, it comes down to text files, Git repos, and agents in containers.
CLI, man.
Yeah.
CLI is awesome. It will
Yeah.
continue to be
So
awesome.
there's been a new. It's sort of like a Git spec is or spec kit came out from GitHub, um, and the thing it does is it's a CLI tool, just like what we've got, but
Yeah.
it dictates a workflow, and it's largely just prompting. So, like, here's the how to do the plan. Can you see that all right?
Yeah. Yeah.
Yeah. So it's like this is really just it's just prompting what they've done. So we could probably jack that into Codex. I'll bet people already are. But yeah, having file access in a container with an AI, it just feels like that's the place where everyone ends up. Um,
Yeah.
I-
Yeah. And you can also always skim it with GUI, but as I said frequently,
yeah,
I really have very little time for GUIs.
yeah. Well, that's funny you say that because what I was wanting to talk to you about today was GUI. So what I've come up with
Hmm.
is turns out that when I told you about that tab manager thing that I was thinking about for you,
Yeah.
um, digging into that, that's actually much simpler than I thought to be able to do it.
Hmm.
Um, but you can also do window positioning. So, like, I can say that I want to make this particular window go to there, and then I want to make this other window go to there. Like, I could display windows like this, and I can control their content. So um, I've also learned how to using faces and views. make just a web server be just another. A web server is just another face. And so, what are you doing over there? You sound like Darth Vader.
I'm not doing anything. Is it my headset? Am I Darth Vadering right now?
Whatever. I can actually deal with it if it's not an obvious issue.
Okay. I'm literally just sitting here. I have no idea.
Fair enough. So remember we talked about being able to display an iframe inside of the terminal by detecting text tags or text lines in the terminal output and then intercepting them in the browser and drawing over the top.
Yes. Yeah.
I think that even that is pointless. What we should do is connect up that tab extension to your computer, where computer is a network of agents, and then control the tabs to display the app. Because why display an iframe if I can display the full web page in a new tab and I can move it around or hide it or close it? And so there's two things I want to hit at here. I'll just lay them out so that I make sure we come at them. The first one is there appears to be a merging of what, I know it's not the OSI model, but basically it goes desktop, applications, windowed content within the applications. But instead, in this model, it almost goes like no more desktop. What do you need that for? It's really just a window manager. No more apps because it's jitters, where it's sort of pulling in web pages to display specific content. So it pulls in a specific face to do spreadsheets or maps or just plain text or editing or whatever. The chat with the agent is just another face that's showing, like I've got it here. It just takes up a third of the screen, whatever.
Mm-hmm.
If you want to browse the actual web, it fires up a real browser tab, browses it, pulls in the content because the extension has full access to all the pages, pulls in the content, and then processes it within the agent computer, the agent computer. And so in that model, the desktop, the operating system has like no point anymore. All you want is to fire up the browser tabs. And if we made this a desktop app that was a Chrome package desktop app, you could ditch the URL bar and the tab headers and all that stuff too. So I'm really saying that is that sufficient? Or I guess I'm saying, what do you think about that as a plan for the UI? It's like, why would we fuck around with trying to pack a window manager into the page when we have a window manager sitting right here on the desktop that hardly ever gets used? I mean, most people just run a window in full in maximized anyway. Like, you know what I mean?
So what would you see?
This.
So you got the interaction. Sorry, I've got a thing in the throat here.
In your throat.
What would you see?
Well, here's one example. In this example here, let's say I'm dealing with Codex. I would see exactly this. I would be chatting and I would say, show me the Google map. And then, whoop, up comes this page on the right, the state board. It's just,
Right. Because you got, well, that's the view, right?
yeah,
So the view comes up.
yeah,
That's cool. And you got your interaction, and you're interacting with the face.
I do
The
that.
face is under the agent under the computer. All happy.
Yep.
So, but what were you saying about the tabs? I didn't quite understand it.
Well, because if I all I do is I get you to install an extension, that extension turns out gives me the ability to move windows any way I like from within the browser. So the extension, the agentic computer can elect to resize the windows, like what you see here,
Yeah.
from the AI.
Okay. Why would it want to do that?
Well, if you were here and you were like, full screen me, it would, Codex would be able to go, okay, he must mean the map, and then it would make it maximum.
Okay. And now you want to type the next thing. Where do you go for that?
Well, you would, if you're connected by voice, you'd be like, hey, give me back the typey thing, or you'd use Alt Tab to get back to it.
There's something here, isn't there?
The point is that all this dicking around that we did about, we need the 3 boxes, we need the chat history, the chat input, the state board. It's like we're designing and then like iframes and how do you get protected content and all that. It's like we already have all that right here. What the fuck?
Yeah, it's the whole point of the tabs and the browser is your chain of thought, as you know, in your
You
meat
can
brain.
still, yeah, but you can still have that here. I can have like multiple tabs, no problem. That's all just part of the AI's view of what's happening on your desktop.
Yeah. So here's an example. I'll obfuscate. So I've got a lot of tabs open at the moment, and I want to. I can't really remember, but I'm pretty sure that at some point I
Yeah, so
talked
you just
to
type, you just either type or you'd
CryptoGo.
be talking with a mic and you're like, I can't really remember, but it was
Yeah,
something about counting goldfish in the wider Edinburgh
right. Yeah, exactly.
estuary.
But also, is the history available? It's like,
Well, history is in, you can, well, first of all, like, I can do that, and now I have history. And second of all, the browser, the agentic computer could cause the history tab to open as the state board, where it's just like, here's
right. So here's an example, and we might be getting too far off the piece here, but what I'd want to do there is say, all right, I really can't remember, but I was trying to export goldfish to my mate down in New Zealand. And I remember at some point there was a problem with goldfish visas. Can you take me to that point in the history?
yeah, and then it would just like work away on the in the background and then pop you up with, it could be a view that just showed a presentation of the search results, or it could be the last page you viewed.
Or it could be the state as well.
The state, what do you mean the state?
As in, if it was halfway through goldfish exporting license.
Oh, like
because
partway
it
through a
would,
form filling thing?
yeah, and it would be
Oh
an
yeah.
external,
Like this is
yeah,
where we got up to. We're still missing this and that.
yeah,
Yeah.
yeah,
So yeah, I just anything you want to do and more than what we've talked about already can be done by giving the agentic computer the ability to control the windows and tabs of your browser on the local machine.
I um I agree. Because nobody wants tabs. Tabs is a hack. Really, you want to just talk to your computer.
Yeah.
You don't want to have to remember your tabs. And,
No.
I've got all sorts of fake things where I've got the flame front to the right
Yeah.
and then tabs to the left
Yeah.
are stale. I don't want it slowing down a computer. It's like, I just want to know, can you not just do it,
Can you not just do it?
Um,
That's right. And so that kind of gives us the ultimate freedom because um, anything else we do is going to be awkward and constrained to be within the browser window. But in this sense, like remember when you told me or pointed out that this area is the most expensive piece of real estate on the planet,
yeah,
and
yeah,
it's like we are now above that.
yeah, yeah. Have we got a next gen browser concept here? I wonder. I don't know.
No, it's more like just a yeah, maybe, but we'll make it and see. It just the thing that's starting to hit me lately is this nesting of purpose. And it started with nesting consensus, where it was like, okay, I've got this S3 bucket, I've outsourced my consensus to the S3 bucket. You can't get away from doing consensus, but you can awkwardly do it in multiple layers and you can do it implicitly. You can also externalize it. You can really fuck it up. But if you just do it in one dedicated spot, the world gets a lot nicer for you. And so it is the same with many other concepts tabbing, window management, um, multiple views of disparate content. Like all that stuff is already built at one level, it's built at the operating system level, it's built at the browser window management level. Why are you doing it again inside a page? Like that's wild.
I think.
This model makes things a lot simpler, dude. Like a lot simpler.
Yeah, no, I'm really pumped about this. I don't know how much effort it will take to get here,
It's
but
actually pretty tiny. And the reason I say that is because it's mostly your effort. The second thing I wanted to raise on this topic was
yeah,
that to take the browser window controls, the functions that allow you to do this, which are like resize window, get window state, get screen working area. There are a small set of maybe a dozen commands that allow you to do anything and everything with the Chrome window. Turning that into an MCP server is
mhm.
trivial
Huh.
compared to the shit that we've been trying to but it's trivial. And the point I want to make here is that the pattern seems to be if you can hook the raw levers of a system up to an AI agent, then the ability for you to control that system requires a significantly less complicated piece of software. It requires almost no software. And the LLM can learn while you use it. So you can just start playing and prompting, and it's usable from day one. And then you're like, you say to the LLM, oh, see that time where I asked you to move one window to a third of the size and the other one to
Mhm.
the full screen. Like, I want that to be called the state board move, and I want you to make a little bit of code that turns that into an MCP tool so that you can call it in one hit rather than it being a range of different things. Go. And then, like, because all the logic is happening server side, so the client stays super dumb, super thin, super lightweight, right? The client's just like, hi, I'm an MCP server. Here's how you control my tabs. And in server side, the AI is orchestrating stuff, but over time, different efficiencies are worked out where pieces of code are called, where the LLM's just like layout, setting, configuration, alpha Z3. And then the code runs server side and pushes all the tool calls down to the client, and then suddenly it all rearranges back to wherever you were on a particular day or some kind of state. And the point I want to make is that it seems, remember I was going on about how I feel like I can make an SMTP server, which has long been considered not something you want to get into. I feel like I can make it pretty simply now by using an LLM. And same with like a hosting platform where I was like, the fucking wild number of things you've got to code for to run a hosting platform in an automated way so you don't have a high salary bill. You need a certain volume to be able to pay for the devs, to be able to make the automation, to make it cheap per server, so that otherwise you got people and that stuff is greatly reduced by having LLMs, but that pattern applies everywhere. It's almost like 95% of all the software ever written doesn't need to be written if you have an LLM and some tool calls.
Yes. Yeah.
And
Agree.
And there's more to it than that. It's deeper than that. It's almost like we talk about tier 3, tier 1, tier 2, but a lot of the reason why the desktop is laid out the way it is with its different apps that you explicitly call and then you save to the file system, then you pull it into another thing, and then all that is really because of the cost of software. But when LLMs can do most of the logic part of that to a suitable degree, like it just feels like the tier 3, I think we were talking about SaaS and web apps, but I think it extends to desktop as well. Like all across the board, phone apps, it comes down to really having one app.
Give me a pause. Yes, because my holy grail that I've been banging on about is I just want to walk up and down, say stuff, and then the screen is just the view. Which now we're talking about sure, NCP for services, tell me the weather. Yeah, absolutely.
Yeah.
But you're saying that actually that also applies to the interface between human and bot.
Yeah. That's right. It bleeds across all levels.
Yeah, I very much agree with that.
Right.
So I've been struggling to explain it, but yes.
Right, and it's like it's
that's the walking up and down thing. Yeah,
it's hard to explain, but when I lay it out, like I'm just going to control your browser tabs, and that's that. And now we've level jumped, like we've excluded an entire industry's worth of application development, which is the web app layout industry.
Yes. Yeah, because who cares? I want to like Star Trek, they talk to the ship and
Talk to the ship, yeah.
Yeah.
Yeah, and so there's another thing that we have in hand, but we don't I don't think we fully understand the implications of it, but it's that all the computing is happening off desktop. It's happening in the agentic computer, and so the privilege point that the desktop has starts to really sort of dissolve. Like it's really just a browser.
Yeah. Yeah, I agree. Wouldn't it be great if, you've got a session on your desktop and it's like, I've got to go out for a walk, and now you're talking to your phone and it's the same session.
Yeah, but that's the thing. That's how this system has that very easily, because all the computing is in the agentic computer, and your
Right.
phone is just another. It's just another view. It's just another interaction with a face. It's the same computer.
Yeah. Yeah,
And you
exactly.
can even say to it, like, you can talk on your desktop, and you can say to it, um, show the something something on my phone, or like play the funky music on my Android phone,
Yeah.
and what is it? Brick my iPhone because it just got stolen,
Yeah.
right? And so the agentic
Yeah.
computer controls all your hardware, controls your IoT devices, your home, your locks on your house, your security camera feeds are being processed by the agentic computer. All of these things are just thin little interfaces. They're like a little I/O port into the computer, like a USB cable, and the computer is controlling down to the devices now.
And that makes the device really lightweight.
Super light, but also immensely powerful, because I'm
Yeah.
calling on every other device that I have affiliation with is also at my beck and call through every other device.
Yeah. Yeah. Precisely.
So that's like the smart computing future that I think we'd been promised, but it had eluded us until kind of now.
Yeah.
Because
And
now you become like
uh,
Star Trek. You can just talk to any device, and then in the background,
yeah.
it figures out what you want as best it can.
Yeah. Yeah. You tap a little smart badge, say something to it while you're walking away from, your console, and it still does it.
Still does it. It's seamless handoff because it's the same computer everywhere.
Yeah. Yeah.
So I think we're like actually oddly onto something. This is not what we were looking for, but
No, it's not at all. But
right?
it seems like we're uh, potentially deleting a lot of the system
Deleting
out there.
industries.
Yeah, it's like why wouldn't you do this? So long as you got okay. So what are the um, how can I kick a hole in this? Connection is one, right?
The
Um,
browser
but the
must be
connection is
connected to some portion of the agentic computer.
right,
Keeping in mind that
but
the agentic computer can be cut off from other parts of it, and it can operate in the dark.
yeah. Yes, and the agentic continues to do the work that you've asked for it, and then you can reconnect
Yep.
um, over an arbitrary amount of time.
Yep.
So you could go wandering in the hills of Afghanistan for ages, having kicked off something, and as soon as you get connection, then you've still got the same supercomputer that
Mm.
you had previously,
Yeah.
and you could do that on any device.
Yep.
This is completely different from what we've been talking about, isn't it? But it sounds fucking awesome, doesn't it? I mean, devices become disposable. It's like I don't care. It's like,
Oh, it should be.
yeah, I want send I now want to be talking to you on my wife's phone,
Right. You can
like
do
a
like
new,
seamless call handover.
yeah. Um, hmm.
I think we hit something good, man.
Um, I think we have.
And it's that agentic computer model.
It is. It is.
Okay. Well,
Hmm.
it's great to hear that you seem sort of actually more enthusiastic about it than me even.
Yeah, I'm just trying to figure out where it would go wrong.
I
Why
promise you
wouldn't
it
it do that?
won't. You know why? Because you deleted stuff.
Yeah.
You repurposed what you already had to do kind of what it has been evolved to do over several decades, like browsers being tab managers. They're pretty good at that.
Yeah.
All right, cool. Well, I'll make it, and then we can use it and continue to sort of poke around at it. But honestly, it's looking pretty good. It's looking like my dream of having just a browser, and it's the only physical thing I need. Is
It's not, but it's not even a browser. It's just one pane of glass that you're talking to.
Yeah, right. It's even less than a browser. It could just be my phone's microphone. Um,
Yeah.
yeah, okay. Um, but yeah, that whole gist of controlling the hardware and controlling hard to do things by an LLM being a massive cost cutter, that's something we really got to sink into. I can see only limited places to apply that now, but if we have the theory that almost all software ever written is worthless or doesn't need to be there in the light of a well configured agentic computer, then we have our work cut out because of the number of targets we now need to hit, which is pretty much everyone.
Yeah. Yeah. And I mean the um, single pane of glass thing is one thing, but there is rich pickings in terms of using the template in order to create agents, and
Yeah,
create views, and so on. Um,
rich pickings.
so yeah, I uh, I was doing I don't know what they call thought experiments again. I was thinking through the use of this yesterday with the hopper, and there isn't a single piece in that hopper that couldn't be done with that architecture.
Right.
Um, I
Epic.
I, uh, I couldn't figure out what to saying, well, we need this. There is no we need this because um, well, take the bootstrapping. So I spent a bit of time thinking, okay, how would I prompt um, inside of that format an agent that makes other agents? And it's like, sure, I just need to make it aware of its own format, give it a place to write to, uh, tell it what tools should be available.
Yeah.
Um, and it's like, boom, you got another agent. It's like,
Yeah.
yeah,
Crazy.
okay. Then it's like, okay, so that agent itself could be prompted to spawn, and this is an interesting one, uh, um, to create other agents that are limited in scope to the area that you're talking about.
Yep.
Um, so talking about a CRM, I only want to talk about trucks now.
Yeah.
Okay. And then, it's like um, it's aware of the overall format, it's aware of its own format, and you're saying, I only want to talk about trucks. Boom, another agent. And it seems like that is all there is to it. which is
I know.
weird.
I agree with you. It's almost tragic, but there's literally that's all there is.
Yeah, yeah, because we've got scoping, we've got action, and agency, we've got store, we've got scale from the compute.
Yeah.
It's like, okay.
All right. So let me move on then to what we don't have and what we should have.
Yeah.
We don't have confidentiality. Now, just before I dive into confidentiality, I had a talk with Ben, which I posted on YouTube, where he was kind of like, look, that is basically like, okay, that makes sense. Like, there's just no argument whatsoever from the against the agentic model. But he pointed out that there was also Apple Silicon is working towards making containers run native on Silicon. So that's not confidential, but it is to say that consumer grade CPUs are starting to become very, very good at running containers. And so you could imagine a version of the agentic computer that was just running on a piece of Mac Silicon, as containers.
That's a fair point. Yeah.
Now, when I explained to him the confidential computing thing with the CPUs giving you confidentiality, he had the same sort of look on his face and made the same sounds that I did when I first heard about Bitcoin. It was like, what? No, how do you? No, you can't do that. But so that sort of indicates to me that the awareness of confidential computing being a thing isn't really that common.
Yeah. Okay.
And also that I can't fucking NVIDIA. This is a very complicated diagram, I'll give you that. But they have been working on confidential containers with GPU support too.
Yeah.
So you can actually run LLMs in the confidential computing environment. And I just, I've been probing this problem, and it turns out that this is just I'll try and just describe the situation I think would be perfect for us, and this is what my initial checking shows is feasible. We would be able to produce a USB key that you would plug into a compatible computer, so long as it's probably like a server or something similar that has the right confidential computing flags enabled. You would boot this thing, which is really just booting like a hypervisor and a management agent. It would sign into our network, and without requiring any additional anything, it would simply start processing confidential container load for purchases online. It would get paid in our intrinsic currency, and because we're going to trust, because we can trust the CPU cert, and in fact we ultimately trust the CPU cert on our computers that run within our controlled environments. What's the difference then in trusting the CPU cert running in a completely hostile environment? Like North Korea could fire up a confidential computing server, and they should be allowed to just join our network and earn money because we trust the CPU certs.
Well, yeah. Then you flop down to the security of the confidential computer, which, prior to quantum, that we can assume doesn't matter where it runs.
Doesn't
All you're
matter.
doing is
Doesn't matter where it runs, right? And so what we've got there is an ability, a new kind or a different kind of permissionless mining, where you mine by doing confidential loads, which means that
yes. So you got a piece of hardware, which is a capital cost,
yeah,
and you got your electricity fine. You could just leave it online, and someone would run their entirely confidential load on
yeah,
your PC. There's nothing you can do about, accessing it. And then you could get paid for it.
yeah.
Huh.
And so
And then you've got a virtual data center. I mean, a
yeah,
worldwide virtual data center.
yeah. So we would run our blockchain on confidential computers that we don't even control, just like how Bitcoin does it, where it's like they don't, like, sure, we'll supply some ignition load, but there's a time where we'd be able to step away and our blockchain would keep running exactly how it was supposed to run, using its own LLMs running on confidentially executed GPUs to continue to perpetuate the blockchain and earning money for people who supply hardware to it. And it also skims a portion of the confidential load that you supply to pay for itself, to do its own work.
Right. Right. It's compute mining.
Mining, but it has a lot of the properties of what the hash mining of Bitcoin does, but it does useful stuff. Like, it's permissionless.
Yeah.
It's easy to check versus hard to do. Like, you could run a computation that took 15 minutes to run, and for you to verify that it ran correctly, you only have to check the attestation that came from the CPU. And so that has perfect asymmetry properties for being very quick to verify, very hard to fake.
Yes.
But it's got
Yeah.
more than that too, because like the problem with Bitcoin is that you could fake the transaction order or records or exclude some stuff and then mine with more power. But because you're running confidential workloads, you can't actually see what it is that you're going to tamper with. So you can't mess with the network in the same way that you can with Bitcoin. So in some aspects, you could consider it stronger.
Yeah. Yeah.
But
Doesn't matter whether you got 51% or not. That's no longer an issue.
right, it's like all that matters is the CPU certs. Like if someone's either infiltrated the CPU cert process, which would be honestly a fucking massive problem for a lot of people.
Mhm.
And you've also got like other things that fall almost for free. Like you can't just turn on a million valid CPUs. Like you know that each one's got a cert, and it all is it's signed by AMD. So you're like,
Yeah.
that's a
Yeah.
it's got
Yeah. So
scarcity.
the last redoubt. Yeah, the last redoubt comes down to the cert.
Yeah, yeah.
And for the time being, everyone trusts certs.
You kind of have to, because it's like, well, so I guess we're like, I mean, I don't know how we end up in these positions where we're just ogling at these like enormous opportunities just sitting there. But to skip ahead a few steps, I think our future is in getting up a confidential computing chain where it can be either on-prem, off-prem, or basically making a way for the agentic computer to be run with consensus and using confidential containers, and then we become a vendor of confidential computing, but also the blockchain we produce is where people trade confidential computing rather than us just being the supplier.
It's better than that. I'll add to that. So take what we've been hearing from likes of Kenya and Uganda governments saying they want to have sovereign control over it. So in a kind of ISO-SI layer thing, it's like what they're talking about is the top layer. They want that control.
Right.
Right now they're thinking, shit, we're going to have to get like 10, 20 million to get a 1-2 megawatt data center built. And then we need to control access to that. That's no small thing.
So hang on. Are you saying that their desire for for sovereignty is actually just a desire for confidentiality?
Yeah, it's like we're not going to be screwed by colonialist, nations anymore. We want control over our data and full stop.
Right.
And at the moment, they're thinking the only way to do that is to build data centers.
Because they can put a lock on it and not let anyone in, right?
Right, but if there is the structure, it's like, well, you don't actually have to do that.
Right. Well, see, because I might have to actually go back to some of the people I met around about 2018, 2019, because I got mad at them because they were like, I want to know if someone looked at my data. And I was like, sort of, like, you can't, how is anyone going to know if it, got read out of the RAM or not? Like, you could tap the RAM and you're screwed. You just need to keep the thing in a locked box. I don't know. But turns out this confidential computer thing gives that to you.
Yeah.
And so, if you talk to those data center guys that want to build a data center, if they do want to build a data center still, and that they are, so, but they should really be focusing on being able to supply confidential computing. And all it requires is getting the right kinds of CPUs in there. And
right. And they haven't bought any yet. And
yeah.
So I don't know what the cost differential is.
The cost is roughly the same. It's a standard fucking server chip. And then you need a BIOS that supports it. So maybe that's a little bit more. But if you're going to get a data center grade rack mount server, it's probably got that kind of control anyway.
I'd imagine it would be it'd be de minimis because when you're on rack servers, you basically get everything.
Yeah, you get everything, right? And the performance cost is, depending on the workload, can be up to 10% of the compute is lost. But in a lot of cases, I think that doesn't really matter. You're going to be like,
data centers, that would only become a concern if you're running at 90% plus.
Yeah. So the efficiency loss is like not that much, but what I'm trying to get at is like, so first of all, if there's a new data center build and they care about sovereignty, then confidentiality is absolutely the way to go, because you can't have confidentiality and not get sovereignty as a side effect. If you have confidentiality, you naturally have sovereignty. You weren't even trying.
Of course. Yeah. Of course you did.
But what I really think is a good model for people, a lot of people want to run stuff on-prem. And so what the model we would push is, you buy this hardware, okay? You want to run on-prem, this is what you got to get. But we can offset the cost of your hardware by selling confidential workload running or confidential mining during the times that you're not using it with your spare capacity. So you buy the hardware, and at first you're only occupying it like 30%, and only from 9 till 5, we'll run it at 100% all the time and turn you a profit.
Oh man, this is we're onto something here. A lot of the racks I was building back in the day for the likes of RBS and the banks, the reason that they insisted on, even they weren't doing supported hardware, they were just doing colo because they had their own team, expensive, own hardware, expensive, and it was the loading was very low. There was a hell of a lot of lost value there.
Right.
But instead, if you, this turns compute into more like an electricity distribution network.
Mm.
So where does the load go?
Mm.
It's not the equivalent of what's happening at the moment is people buy their own diesel generators in order to run their house. It's like, well, okay,
Right.
fine, not very useful.
Yeah. I think this is the future for us. Like, first of all, we're trying to prove the utility, and we're trying to get the developer model right for how can we make a useful computing platform that's dark age capable, right? Like, that's really without all the
Yeah.
fancy confidentiality of degrees and without all the dark edge operation. We're trying to find utility first. Like, we're like, oh, is it actually useful? Is it nice to use? What we've stumbled upon is something that's sort of more useful than we'd hoped, because it's more useful than what we have right now. It's basically this omnipresent agentic computer that's fucking everywhere and on everything. So that's great. I think we've hit the utility right on the head.
Yeah.
But then the second part is, okay, we want to go dark edge. I think that's possible, but really we want to be going hard on confidential containers and the ability to run them, because not everyone's going to be okay having no data center. Some people need to have a data center, but
they probably will, but that would be wrong-headed of them.
Well, no, some like if you're running, say you're a DARPA, like, or the US military, you probably wouldn't want to run only on other people's confidential container infrastructure. You'd need your own for reasons, right? Like,
yeah, but I'm struggling to figure out what those reasons are. So long as you trusted certs.
nah, well, because it can be for dark edge reasons. Like, you want to be a fully functional dark edge network cut off from the wider community.
Ah, right. Okay. So if you're running on other computers
Yeah.
or other people's computers, they could deny service.
Yeah.
And then
But then like, even if you are running in host, running using confidential computing so that none of your sysadmins need to be trusted. The janitor doesn't need to be trusted. All these people, like, what are they gonna? They can't touch the silicon. Like, running confidential is just better anyway. And then you've also got this way to sell your spare capacity at a commodity-like rate. So plus you can purchase burst.
Yes.
And backup, like resiliency. It's like,
that's nice as well, because
right? The failover.
Yeah, you get a big contract in, you don't need to do the whole kind of pizza box shuffle where you're having to slide in service as quick as you can.
Yeah, or
and then,
if something goes offline and it was critical, you can just buy burstable outsourced from the guy down the road and you can take your time to fix your server. It's not like a fucking board meeting about a server being offline and where is the truck that has the parts.
Yeah.
Which is a fucking stupid fucking thing. Anyway.
Yeah.
So I just...
Oh man, this has been so useful like 15 years ago when I was moving banks and literally powering off servers,
Dude,
put them in the
people are
back of
still doing
trucks.
that. I had a meeting one time with a company that specialized in moving server rooms.
Yeah, it's no small feat.
Nah, dude.
Man, we're getting paid big bucks
Yeah,
in order to move a bank's infrastructure from one place to another.
yeah.
Hmm.
I think this is our future, buddy. And it's sort of like, yeah, the agentic operating system, super useful. Lots of places we can apply it. But we got to stay focused on, I think, the end goal is running on confidential containers. And from what I can tell, it's actually not that hard. So now you can take this with a grain of salt, but the estimated amount of code was oh dear. I am so sorry, I can't find my stuff. Anyway, it came out to being like there's a bunch of pre-built things that we can largely cobble together, and you can distribute this like installable image that boots up, finds our chain, and then starts trading confidential compute. And it was probably the pieces were tiny. It was maybe like 10,000 lines of code max. So, you know, and this is where I wanted to really point at the beauty of having an LLM, right? So how I would imagine it goes is you put this stick in, the first thing it does is it boots up and it talks to our chain, which has LLMs attached. It tries to run the base program, the happy path, but as soon as it gets stuck, the LLMs in the agentic computer have a look at it and figure out what's the best thing to do. So rather than having to make an installer that is continually needing to be bug patched and figure out these quirks and what happens with this weird piece of hardware, if you jack it into a piece of hardware we've never seen before, the LLMs go to work treating it like, oh, hey, great, we've got a new computer in the lab. This is what we know works and this is what we don't know. So here's a plan for some experiments so that we learn for next time, but also we can get this piece of silicon up and running in the pool. And so the LLMs sit there and help you figure out how to configure it, how to get it working the way it is. They also do continually optimizations like balancing, like turning on different tunables here and there to be like, we can squeeze more performance out of this if we switch to like large paging support or some other thing. And they can manage the experiments that do the tuning that I think a lot of the cost of like making your own hypervisor or those things cost a lot of money because you need code to do these things that an LLM is sort of gonna get right enough.
Yeah. I agree.
You plug in
Which removes another layer.
straight away you're jacked into the AI and it's whirring away working out how to configure this piece of hardware for you. No more like, what's the sysadmin for? You know, plug the thing in, make sure the net connects because we can't help there, whilst talking on your phone to the AI and it telling you what it needs you to do. It's like, okay, power cycle. Do you see any lights? Send me a photo. Okay, can you just turn on the video? I'll look at it. Right?
Yeah.
What skill is required there?
Absolutely none.
And what code is required from us, right? Not very bloody much, honestly.
Not any more than we're already thinking about.
No. And then now we've got yet another machine sitting in the Cocoa pool, ready to do confidential container computing, and all the hassles of the software required to get it operational almost gone.
Yeah. It could also the agents could also be prompted because your intent of I've plugged in this pizza box and it's now got network and power. Here it is. The intent is clear. Add it to the Cocoa pool,
The Cocoa pool.
and it could be as simple as packing boxes in Amazon.
Pretty much, dude. And they can come pre-configured, and it's like, just give us net, and we'll figure it out.
Yeah. Nice. That's really nice.
So that's our future, right?
I think so. And also, when you talk to Dark Edge, it's essentially the same. It's like install this app, and the LLMs will work out. And now you're selling some cycles on your phone, and you're getting access to the virtual data center.
Yeah. So this was sort of the loose kind of estimates. You know, like 2,000 lines of code. Like, it's not really, 20,000 lines of code. I don't even buy that. Like, we don't need this control plane API, web UI. That's 10,000 lines right there. The receipt composer, is it 2 to 4,000? I'm not sure. A lot of that would be auto-genned anyway. Capacity agent, right? Work puller, lifecycle, log metrics. We were going to do that anyway. That's the marketplace balancer. So really, it comes down to round about 10K at most, and then you get out like these beautiful things. Like, this is what you get back when you run some code. It's like, here's your signature, here's the job, here's the CPU cycles burned, the cost of it, here's the fucking GPU attestation. Like, it's like, that's what a fucking transaction record should look like, man.
Yeah. No, you're absolutely fucking right. Absolutely fucking right.
That's one tick of the agentic computer, and it comes out like that you can't fucking argue with it. And just for shits and giggles, it's run in multiple locations to concur. How the fuck do you get better than that?
Yeah.
I think.
Oh, that's sweet.
This is us, right? This is attainable. We can do this. We can do this even with the tools we have now.
Yeah. I agree. Man, that's sweet.
That's fucking cool, right? That's everything we wanted.
Yeah. Right. Well, and just go around the boy on that one, which I think we're both in roaring agreement on.
Yep.
I got something to bring to the table here, which is a paper that was released 5 days ago by OpenAI, which is quite interesting.
Thing? What's it called?
Yeah. I can send you a link if you want. It's called Why Language Models Hallucinate. Yeah. That, I think, speaks to what's going to be happening in the next 6 months or so. And, we were talking about the S-curve and whether, I was disappointed with 5 just because I was being spoiled with previous launches. I think this could be a double S-curve. Well, I remember when we were talking about it when 5 just came out, and unless they change something drastically, then we're going to be, leveling out on the S-curve. I think this is the thing that
Is it the
will
next
make it.
boost?
I think it's the next burst,
I
and
I disagree with you, and I'll tell you why. It's
mhm.
because all that's going to happen from solving the hallucinations is more of the same. The curve is about change. This is all just stabilizing. It's not new. It's just doing the same thing that's already usable right now and just making it incrementally better with a diminishing return. Like it's making it more closer to perfect.
Um, I disagree, and I'll say why. So, by doing the yes/no training, um, we're yeah, hallucination is not the problem here. It's how accurate and reliable the results. It's confidence levels.
Mm. And
What
so
what
there was a
was
threshold that was passed. GPT-4 had intelligence but wild hallucination problems. But the intelligence was more than the hallucination. And it was just some natural feeling for your own personal use that the good outweighed the bad. If you removed hallucinations or got them to their lowest theoretical possible amount, it would probably still feel a lot like GPT-5.
It may feel like it, but the if you look at what tasks the models are good at the moment, they are well-formed logical problems like maths and code.
Mm.
Uh, if you add in confidence levels into the training, then you're going to get the similar sort of thing with reading legal documents or uh, writing,
Yeah.
screenplays or
Look, I
that sort
mean,
of thing.
I don't know. I don't know how to explain it, but it's like the feeling I have is that the S curve of innovation has sort of peaked, but the rollout is coming. You know, like the rollout hasn't peaked, not even close. But the ability of the things, it's so good that like, what more, what more do you want? Like,
Yeah, but I guess, and this is a complete guess. Um, what I'm saying is, with the introduction of confidence levels into the training set, remember when that kind of feeling you got when Codex could just write more code than you could write in a lifetime.
right?
Um, that expands now to areas that are less well formed in terms of, language.
Right.
Um,
But I thought
so
that it already was better at that than code.
no, um, take the translation issue. Uh, so the translation problem was around idioms and niceties, um, and the they still had to have a human in the loop
No, like
because
look at this claim, right? Hallucinations will be
uh,
eliminated by improving accuracy because a 100% accurate model never hallucinates. And they're like, no, accuracy will never reach 100% because, regardless of model size, search and reasoning capabilities, some real world questions are inherently unanswerable. I would argue that your translation problem, to some degree, falls into the unanswerable category, and what you've come up with is a system that involves human in the loop to make the unanswerable answerable by a human. But it's not actually answerable by simply having higher and higher grade AIs. You have a matter of taste on hand.
mhm. Yeah, sure, but so where do you offload that question of taste? Can you offload it to the AI where
Nah,
it's going to?
it needs an AI that never asks you the same thing twice and a bunch of humans to confirm the taste. Even amongst the humans, you're going to get disagreement on this matter. I promise you.
Oh yeah, but then you flop to the problem of which human is the arbiter of taste.
Yeah, but all that we need is a model that is correct enough that it knows when it's already got the answer from a previous thing, and we need a harness that can allow the model to search and grind and find it, so that the humans are never being they never have to repeat themselves.
Yes, that is true. The question is, at the moment, with the translation thing, we've got editors in the loop. So what we're basically saying is the editors have the better taste, but those editors vary in quality, whether they've had enough coffee in the morning, whether they can be arsed. There's a whole bunch of
I feel
stuff
like
there.
what I've lost sight of what we're trying to.
What I'm
You were
pointing
saying
at
that
here
the S
is,
curve's about
yeah,
to take off again.
the S curve in terms of zero shot, I think, is going to increase for areas which are less well defined than code at the moment.
Right, but even then, it's still getting very close to saturation for the majority of humans. We look at these things and we're like, like I've been writing code probably longer than I should have, and I look at the code it makes and I'm like, that's pretty damn good. It, you know what I mean? Like it's sort of saturating as to what it can do versus what I can find fault in.
Yeah, I guess what I'm saying is that same situation is not the same if you were to write a more human
Are you saying that
level
you've
task.
noticed it to be particularly poor at the task of translating?
Yes, as an example, but you could also ask it to write a poem and it'd be shit. You could ask it to write an essay and it would be factually correct, but wouldn't scan. These subtle cues that are more human have to do with judgment. Now, judgment is a matter of a competence level metric. Someone has more judgment and does better. Someone does poorer and does worse. That is a metric which they appear to be aiming at adding into the training models, because the whole point of the this paper, the thing that really stuck out is, say if you were given a multiple choice uh, questionnaire and you got 5 answers. One is like, yeah, it's never going to be that one. One is obviously wrong. So you've gone from a 20% chance if you were just to choose at random to a 1 in 3 chance if it was just random. And the training models appear to be getting trained on gaming the system as opposed to getting the right answer.
Okay.
Does that make sense?
That's all cool. I'm just like, in the nicest possible way. So what?
Well, the point being, these areas where the models are poor in, which we're not really concerned with at the moment because we're in Codeland, but the models are going to the same kind of, oh shit, that's fucking brilliant. Will go into the areas that require more judgment,
Okay.
and
All right.
it'll do it quite well. And I suspect that's where I guess this is the point of bringing this up, is just to highlight. I think in whatever the next cycle is, let's call it 6 months. That's where they're aiming at, because the they've kind of topped out all the maths metrics, code metrics. It's like diminishing returns now, but there are still areas.
Oh yeah. So I guess the future is that we're going to just see more and more saturation of our measures of intelligence. Like these things will, whenever we can come up with a way to measure intelligence, it takes less and less time for the models to saturate it.
Yes, and if they are looking at this as because when you get to 98th, 99th percentile, it's like, are we really going to, squabble around
No,
the
no, we're not.
11.5%?
Yeah. So I guess
It's
the only thing that we have to really concern ourselves with is, are we pointing in a direction where our position is strengthened from the models getting better? And I think that so long as I think first of all, the agentic model is 100% the best way to take advantage of any model anytime. And then the second thing is that if we follow this pattern of treating hardware and network applications as just purely levers that get connected to a model, then the better and better the model gets, the better and better the operation of the hardware gets for no effort of ours. And so it just sort
yes,
of cements the
yes,
coffin of application code. Like, application code is no longer needed. You shouldn't be writing it anyway. You should be
yeah,
just jacking up these LLMs, and then everything becomes plain text, prior knowledge, the harness by which the AI can operate on, and can you find a way to plug your system into the AI using MCP? I think that's the game.
yes. That is definitely still the task in front of us. I guess what I'm highlighting is the kind of near future, which is if models get better at questions that require judgments, then when we what's a good way to say this? When we get to do the whole kind of hopper of Dreamcatcher stuff, and we try and see, is this person's effort worth more or less than someone else's? Then, because it's got this idea of I don't know as a metric, it should get better.
Oh, okay. Yeah, that's cool.
And there's nothing that we should do. There's no actions on
All right.
that, but I'm just kind of raising that. I think probably in about, who knows, 3-6 months, year, whatever, it's going to get very good at its judgment because it
Great.
has
Well, okay,
this
so what
idea
you're
of
saying is that
confidentiality.
for the ambient attribution agent, we should start to see increasingly powerful abilities to make a judgment with very little prompting, very little background research, and stick at it.
Yes, and also having an agent run a company, for example, becomes much more reasonable
Right.
if the models go down this, if they do go down this route.
Yeah.
They've just done a
Okay.
white
All
paper.
right. So what now for us?
So
I presume I know I am getting the agentic computer online in whatever crustier form I can initially manage, and then I'm lobbing it over to you to do prompting on, and then we work together to iron out the kinks so that it is a promptable system, right?
yep. And the first thing I'm going to work on is an agent creating other agents, and then probably throwing a few problems at it and seeing where, if any, places we fall down. I can't see any at the moment.
Okay.
And attribution will be one of those. Yeah.
Okay. Okay. And additionally, I'm going to not do any UI work whatsoever because I'm going to make this little browser extension that lets the AI control your browser tabs to just deal with all that.
Yes. Yep. Yep.
Okay. So what? Now what?
We keep at it, I guess. Yeah. Hey, now what? Yeah.
Now what and then what? are kind of
Yeah.
our issues.
Well, they now what is keep at it, and then what is I start to create or we start to create agents in order to do the tasks that are
Yeah,
in front of us.
yeah. And so
Um,
and then we'll keep pointing the machine at. We got to get to ambient attribution because what we see is every piece of software ever is a target, and we need a lot of help with that. And that means equity arrangements that are on the fly.
yeah,
Um, and then
yeah.
we need to point at getting confidential container capability up. So that's the blockchain. That's the dark
Would it be?
chain.
Um, I say this with hesitation because it might not be now, but we've obviously got this guy who's literally got a budget to build a data center right now. Would it be worth getting him on a line, talk to him, or not yet? I don't know.
I think you want to talk to him and make sure that he's aware of confidential computing.
Mhm.
And then I think you need to be probing whatever decision makers you can to make sure that they understand confidential computing is an option and to try and figure out how they feel about confidential computing giving them sovereignty.
Right. Yes. Which is that's the whole reason that they're building a data center is because they want data sovereignty.
Right.
Um,
And
and if
so,
you can
and the
say,
thing is, like,
hey, how about,
if they want data
sure?
sovereignty, then so will their neighbors for similar reasons. Because, as they
Yeah,
say, your geography is your destiny. But if they make it with this confidential model, they can share workloads or they can sell workloads to their neighbors and not risk the confidentiality of those workloads, not risk the sovereignty of it, which allows people to sort of get a leg up and help each other out locally rather than having an outlay for their own systems.
right. And then availability comes through those agreements. So what you don't want is you go to war, Uganda and Kenya go to war, and they've been sharing um, compute. You don't want one side being able to turn it off like Russia turned
Yeah,
off gas.
yeah, that's right. So you could always spread it around. I mean, that's one safeguard, and you could have some that's your own, and you can farm out the non-essential stuff, like all those types of options become
Yeah,
for you. But basically, I think the thing we got to drive is like confidential compute. If you need to have that if you're building a data center for the future. Like this is the way to do security, regardless of whether you run our software or not.
right. And so to go over the usual CIA thing, so confidentiality is inherent in the CERT. Data integrity is inside of the system, and availability is variable. You can share or you keep it all
Yeah, so
inside.
availability is the thing that can be denied to you. Like you can be denied access to computing resources based on their physical locations. However, to be the most resilient to denial, you need some in-house and some external because you could be denied.
Yeah. That's exactly. It's like you're never going to go to war with all the world, right? There's
No,
always going to be some
and so like
states out there.
you're more available if you're able to maintain your confidentiality and be in several different places at the same time because it's just that's more
Yeah,
available.
yeah,
But a lot of the
exactly.
time, you
Yeah,
have to trade confidentiality to get that.
not now though. Not with this system.
Yeah,
Um, and integrity is dealt with as well, isn't it?
it comes as a side effect of confidentiality.
Yeah.
Like I never thought of sovereignty being a side effect. I always thought sovereignty was a prime motive, but actually it's a consequence of confidentiality done right.
Okay. Well, I'll see if we can get a call jacked up with this guy. He's they haven't broken ground yet, so
So they definitely haven't bought servers, I'll bet.
yeah, yeah.
It's all it needs
So
is the silicon. It just needs the right AMD silicon.
yeah, yeah. Okay, okay, cool.
All right.
So
Well,
I'll do that. I'll see if we can get that jacked up, and yeah. So we've got the what's next. We got the data center guys. The hopper is basically just the hopper. It's just a bunch of test ducks. As soon as we can, we get attribution up.
yep. Because then we
And
can
then go
work
from
as
there.
a team, and we can start splitting returns even internally.
Yeah, precisely. Okay,
Sweet.
stick a flag on it. That sounds like a plan.
All right. Okay. Well, that's cool. I'll stop recording, and that's that, I guess.
Yeah, I think it is. Yeah, just keep doing it.